In this video, we're going to be looking at uncertainty, percentage uncertainty, absolute uncertainty, and relative uncertainty. First of all, let's consider two terms, error and uncertainty. Error and uncertainty both mean exactly the same thing, except that errors sometimes have this element of a mistake with it. So for the purposes of this video, I'm going to be using the term uncertainty. Let's take, for example, two measurements done with the meter rule. Let's say we've got 76 millimeters, and the uncertainty in that will be plus or minus 1 millimeter. So the measurement of the meter rule will be 1 millimeter. Let's take a second reading of, let's say, 48 plus or minus 1 millimeter. In this case, the absolute uncertainty for this measurement is 1 millimeter in both cases. However, if we consider what percentage that is of the actual measurement, that is what we mean by relative uncertainty. So this here is the absolute uncertainty. When we take this absolute uncertainty and we divide it by the actual reading, we get what is called the relative uncertainty. So let's take the absolute uncertainty of 1 millimeter and we divide it by 76. We get the relative uncertainty of 0.013. If we do the same thing with 48, we have 1 divided by 48 and we get an answer of 0.021. If we look at these two readings, 0.013 and 0.021, we can see that the reading that has 76 plus or minus 1 has a smaller relative uncertainty than the reading of 48 plus or minus 1. So in this case, relative to each other, the reading of 76 has a smaller uncertainty. Percentage uncertainty, therefore, is just this value expressed as a percentage. So that therefore is 1.3%, and that therefore is 2.1%. So absolute uncertainty, relative uncertainty, and percentage uncertainty. Now the question is, what do we do when we have more than two uncertainties? We have, let's say for example, we've got an equation where we've got let's say half mv squared. We've got an uncertainty of m and we've got an uncertainty of v. When we have two quantities that are multiplied by each other, we actually add the uncertainties. So let's say that was an uncertainty of 4.5 and let's say this was an uncertainty of 3.0. Let's just for now ignore the squared. These two would therefore be added together to give a total uncertainty of 7.5%. The squared bit here makes it very interesting in that if there is a squared attached to a quantity, that uncertainty is doubled. So really, the true value of this one should be 2 times 3, so that's 6 plus 4.5, so your total uncertainty here should be 10.5. Always remember, if quantities are multiplied or in other instances divided, you add the uncertainties to get the total uncertainty of that concept. However, if one of the quantities has a squared linked with it, or in fact if the entire quantity is squared, you have to double that particular uncertainty. If there is a cubed attached to it, you then triple that uncertainty. Let's now think about, we've spoken about adding uncertainties. We've also thought about the relative uncertainty. Now, taking the relative uncertainty of a measurement only really applies if it is a single measurement. If you have a range of data points, then you need to do something slightly different. Let's consider, if we've got 0.27 and here we're talking about measurements of millimeters, 0.29, 0.26, 0.77 and 0.26. In order to get the uncertainty in this, we need to first of all know what our range is. Now, in order to get the range, we need to exclude the anomalous data point there. And so what we'll get is a range of round about 0.03. That is the range of the data points there, from 0.26 to 0.29. What we then do is we take half of this range, and so the uncertainty here is 0.0015. Sorry, 0.015. So that is the uncertainty in this, the absolute uncertainty in this range of data points. If we want to take the relative uncertainty, we've got the absolute uncertainty there. We take the mean of our readings. So the mean of the readings there would be round about 0.27. Let's say it is 0.27. We take our absolute uncertainty of 0.015 divided by 0.27. You then get your relative uncertainty, which can then be multiplied to get your percentage of uncertainty.